All right, to solve such questions, the first thing that we need to notice is the constraints. We know that for all three, x, y, and z are integers, right? So that's the first thing that I will take a note of. The second thing is this particular inequality, which is x minus y minus z is less than 0, right? So what I'll do a little bit of transformation. So I'll say x minus y is less than z. So if I have to plot this information on a number line, I know that x minus y will always lie to the left of z. Now I do not know the absolute position of any of these variables. I just know that whatever the positions may be, I do not know where 0 is, I do not know where 1 is, I do not know even know x minus y is positive, negative, whatever it might be. The relative position is as such wherein x minus y is always lies to the left of z. So that's the information from the question stem. The other thing that we want to note is what the question is. We want to find if z is greater than 1. Okay, so that's what we are trying to find. All right, so quick recap. We know x, y, z are integers, which means any of their operations that we do in terms of addition and subtraction will also be an integer. I also know from the question stem that x minus y lies to the left of z. Now the first statement is x minus y is greater than 1 minus z. Again, a bit of transformation that we will do. X minus y plus z is greater than 1, right? I'll just put these 2 points, right? I'll put x minus y, I'll put 1. So the first thing that should strike us is if x minus y lies in this region, right? If x minus y itself is greater than 1, z will always be greater than 1 because z lies to the right of x minus y. So if x minus y itself is greater than 1, z is greater than 1. So I think that's fairly straightforward. That's what statement 2 is, but we'll look at it when we look at statement 2. But then that is the first thing. So I do not have to test for any of the regions which is which in where x minus y is itself 1 or greater than 1, right? Now let's look at other regions. What other points could be? The other options or the other possibilities is x minus y is 0. Now if x minus y is 0, z or z has to be at least a little more than 1 to pull the entire value towards the right of 1. So x minus y plus z, if it has to move here, that compensation of this distance has to be done by z. So in this case, z is guaranteed to be greater than 1. Now this is like the worst case scenario, right? Now the if I further move x minus y towards the left of 0, in which by which I mean if x minus y is negative, so let's look at that scenario. This is 1, this is 0, and if x minus y lies to the left of 0, wherein x minus y is negative, to move this sum towards the right of 1 will will be only possible when z is greater than 1. Not only greater, it is much greater in terms of it's compensating the entire kind of say negativeness of x minus y and is moving the value towards the right of 1, right? Which in this case as well, your z is greater than 1. Here as well, your z is greater than 1. Here anyways, z is greater than 1. So in all of these three scenarios, your z is greater than 1, which means statement 1 is sufficient. We can strike off B, C, and E. Statement 2 is fairly straightforward. I think many of us got that. However, just to complete the discussion, I will go over it. So y minus x is less than minus 2. Just multiply it by minus 1 on both sides. So x minus y is greater than 2, which means if this is 0, this is 1, This is 2, x minus y itself lies on the right of 2. Z will anyways be, the value of z would be more than 2, right? So which means z is greater than 1. So this statement is also sufficient. The answer is